Welcome to my How video for problem number 2. Problem number 2 involves finding the limit of the nth term of a sequence when that term is a quotient of two functions. Let's get started. For this problem, I see that a sub n is a quotient equal to a continuous function f of x for all positive n. And because a sub n is a quotient, I suspect I will find the limit of a sequence using L Hopitals Rule. Let f of x be a continuous function so that a sub n equals f of x for all positive values of n. Repeat L Hopitals Rule for f of x until we find the limit of f of x as x approaches infinity, so that the resulting limit is not expressed as an indeterminate form. We begin by finding the limit of f of x by direct substitution, in which case we find our result is an indeterminate form. So now we apply L Hopitals Rule for the first time. By L Hopitals Rule, we know that if, by direct substitution, the limit of a function f of x takes an indeterminate form, then the limit of f of x equals the limit of a new function defined as the derivative of the numerator divided by the derivative of the denominator. Unfortunately, the result from applying L Hopitals Rule the first time is yet another indeterminate form. Therefore, we must apply L Hopitals Rule a second time. As before, we apply L Hopitals Rule by taking the derivative of the numerator and denominator independently, then finding a new limit by direct substitution. Unfortunately, again, the result of our second application of L Hopitals Rule is yet another indeterminate form. Applying L Hopitals Rule a third time will do the trick. Upon our third application of L Hopitals Rule, our result is a limit of 0. Finally, by the theorem for the limit of a sequence, we can say that the limit of a sub n equals the limit of f of x equals to 0.